All right, so in a few minutes ago, I just graphed this by, well, the whole. All right, so let's try this again. I know that the slope in this equation is here, it's -2, and I know that the intercept is 4. And so I can start the line at 4, and then I'm going to go down 2 and sideways 1. But then I can continue doing that in order to make a better line. So let's see. Down 2, sideways 1 goes here. Down 2, sideways 1. Down 2, sideways 1. Down 2, sideways 1. Down 2, sideways 1. Okay, now I've got a nice reliable line, which looks like that. Okay, so I used the method that we've used previously, which is the slope-intercept form. Now we're going to use the new method, which is to figure out we're using algebra, what the table is going to be. Okay, so step 1 is to write the equation y equals -2 times x plus 4, and then I'm going to replace x with something. In this table, I know that x is -2, so I'm going to be replacing x equals -2 in for right there. And what is the word for replacing a letter with a number? And so the word for replacing a letter like x with a number like -2, the word for replacing a letter with a number is what? We learned it yesterday. Evaluates. So I'm going to be replacing this x here with -2, and that's because of this right here. So I'm going to take x and erase it. So there goes x, and I'm going to replace that with the number -2. So playing the role of x today will be the number -2. All right, so I've got now to evaluate. Y equals -2 times -2 plus 4, and I'll pause for you guys to evaluate that for me. All right, in fact, -2 times -2 is +4, plus 4 is 8. And that means that I can put in this part of the table, I can put the number 8. So the first solution to this equation is -2, 8. So let's graph that. So if I were to put a star on -2, 8, so that coordinate is x is -2, which is over here, and then up to 8, and then there is the position that I just found. But it's exactly the same point that I would have gotten if I used my slope equation, starting at 4 and going down 2 and sideways 1. So it's a different method, but we found exactly the same point, -2, 8. In other words, this point is on the line that I knew before. All right, so let's try it again. So erase your boards. We're going to start with a nice clean equation. Y equals -2 times x plus 4. And I know this one, and so now I'm ready to do the other one. So what do I replace? What do I replace y with? Not 2, not 8. What do I replace y with? Not 0. What on earth would I ever replace y with? Okay, it's -2. So y is -2. And to just make sure that you don't replace x with -2, you replace y with -2. All right, so now that I've got my equation, I'm ready to replace y with the number -2. Okay, and then this is, what is it called when you're trying to solve for something? Algebra. Yeah. Yeah, and in algebra, I want to move things away from the x. So it's +2, right? And then I put that over there. Why wouldn't I want to do that? Yeah, I want to move things away from the x. How does the x feel if stuff comes towards him? X hates numbers, and he wants numbers to go to the other side of the wall. So he wants stuff to move this way. So let's do the opposite of plus instead. The opposite of +4 is -4. Big long line. -4 can go here on the other side of the wall. I still see some people who are putting their -4s on the same side of the wall. It's been a while since we did algebra, so those mistakes are coming back again. It goes to the other side of the wall. Other side of the wall. Cancel your opposites. -2 and -4 make how many? No, it's not positive. Okay, what's the opposite of +4? So underneath plus, put minus. +4 -4, and do the same thing to the other side of the wall. Then cancel your opposites. -6, I agree completely. Thank you. -6 equals -2 times x. Now this seems complicated. First, what's the opposite of times? Divide. What's the opposite of times -2? Divide by -2. All right, so we're not adding here, we're timesing. So the opposite of times negative 2 is divide by negative 2. And I can tell that's true because negative 2 divided by negative 2 is how many? 1. And I wanted 1. All right, so that's the reason why it's the inverse. Okay, so do the same thing to the other side. Cancel my opposites. And what's negative 6 divided by negative 2? 3. Joe is just setting things on fire over there. So my solution is 3. Okay, and I can put a coordinate on that point as well. So 3 comma negative 2 needs to lie on this line. So I go sideways to 3 and down to negative 2. And look there. So my points 3 comma negative 2 is on the line that I drew. And also the point negative 2 comma 8. And again, this blue line was the line that I drew using mx plus b form. So starting here at 4 and going down 2 and sideways 1. So either one of those two strategies is a good way of graphing. All right, next question. Erase your boards. Here is the next question. This is exciting. All right, so I'm going to use the old strategy first, the mx plus b strategy. And so let me erase this table to start with, because I'm not going to use it for a little while. And let's turn this into mx plus b form. So y minus 4 equals negative 2 times x plus 3. And my challenge is to get y by itself. So in mx plus b form, what makes mx plus b is that y is over here on the left by itself. And then there's some number multiplying x and then some number adding. So what I'm looking for at the end is that y is equal to something x plus something. So I need to get y by itself. And this is, again, those of you who were asking what is the distributive property good for, this is a good example of something that's good for. So first I'm going to distribute. So let me put up my wall here. And so I distribute negative 2 times x as well as negative 2 times 3. So that I draw those arrows to remind myself that I'm timesing both things. So the first one is negative 2 times x, and what's negative 2 times 3? 2 times 3 is 6. All right, so negative 2x minus 6 on this side, and then the other side is y minus 4. And I'll remind you of the goal, which is to get y by itself. So what's preventing y from being by itself? What kind of 4? So Valerie, how do I get y by itself here? Start by saying this out loud. No, it's already my add 4. Do I put that under the x or do I put it under the 6? I put it under the 6. Don't put 4 under x. Put it under what you can add it to, which is the 6. Big long line that means equals, cancel your opposites. And this wasn't that hard. Y is equal to negative 2x plus 10. It's not plus 10? What is it? Negative 2. All right, and I'm now ready to identify my slope and my intercept. I have achieved my goal of getting this into slope-intercept form. The slope is negative 2, and the intercept is also negative 2. So that means I can start my graph here at negative 2, the intercept, and then I go down 2 and sideways 1 again. So down 2, sideways 1, down 2, sideways 1, down 2, sideways 1. Okay, and then I'm going to connect those with a line. All right, so there's my line. And I would just like to remind you that that's the line that I drew from the equation y equals negative 2x minus 2. In other words, using the old strategy. So now we're ready to use our new strategy. What is the new strategy, somebody? Not distribute, using this thing. What's this thing? It's a table, and what is it that I'm about to do? Okay, I'm about to evaluate and figure out using algebra. Thank you, you're doing great. Can we all say evaluate? I've got one person saying evaluate. Nice job. So start with a nice fresh equation. You're not doing anything to it. Nothing scary is going on. And I'm about to replace x with negative 3 is going in there. So I'm going to pause for you guys. Alright, so let us replace the x with negative 3. So there goes the x, and I'm replacing him with negative 3. Alright, and again, this looks scary, but it's okay. I'm going to distribute this side. Negative 2 times, I'm using order of operations. Like I said, this stuff applies all the things you've been learning, right? So at the very beginning of the year, we learned order of operations, which says parenthesis first. And what is negative 3 plus 3? Yeah. Jasmine, negative 3 and positive 3 make how many? This one here. Negative 3, positive 3. What do you get? 3 minus 3, Jasmine. 3 minus 3. 0. Okay, and then this other side is y minus 4. Okay, I'm just using order of operations. 2 times 0 is 0. So y minus 4 equals 0. And Crystal, what's the opposite of minus 4? Okay, to both sides. Big long line, that means equals. Y equals positive 4. So I would say when x is negative 3, y is positive 4. And let's check to see if that works. So I should go sideways to negative 3 and then up to positive 4 and put a dot right there, and yes. So yes, negative 3 comma 4 is a coordinate that was on the line. Again, the line that I found by putting a point at negative 2 and going down 2 and sideways 1. Okay, so I could use either of these two methods. What am I going to do next? Somebody make a prediction. I'm going to start where y is negative 2. This was 4, right? Positive 4. Let's make a prediction for what this is going to be. Yeah, it's going to be 0. It's right here. So my prediction is going to be x equals 0, because I already know what point it is. All right, so let's give it a try. Y minus 4 equals negative 2 times x plus 3. A nice fresh equation, and I'm going to replace, in this case, the y, replacing the y with what? With negative 2. So that's now negative 2 minus 4. And negative 2 and negative 4 make negative 6. And I'm going to go ahead and distribute in this step. Why not? Somebody remember what do you get? Negative 2x, not plus, minus 6. And then in my desire to get x by itself, I'm going to start by adding 6 to both sides. Cancel your opposites. You guys can finish this on your own. Negative 6 and positive 6 makes 0. Negative 2 times x, divide by negative 2. And you are no longer mystified by 0 divided by 2. You know that 0 divided by 2 is 0 divided by 2 is 0. Which is exactly what I was expecting. Eureka! X is supposed to be 0 right there. So 0 comma negative 2 is in fact a point that's on this line. 0 comma negative 2. Okay, you are absolutely sure that you don't want me to do another one? Because I will.
Can you do one that has like 2 x's and 2 y's?
There you go.
Fantastic.
That's a perfect request.
And thou shalt we see.
Okay. I'm actually going to have to make a separate recording because I only have 1 minute. So I'm going to come back and do part 2 by request, one that has 2 x's and 2 y's.